In this session, we are going to discuss about the concept of recursive functions in C. So basically, we have seen how a function is getting called from a calling function. Recursive functions are functions that call themselves. So basically, a function will call itself in order to solve the smallest version of its task until the final call is made, which it does not require to call itself. So the theory concept, it may look pretty vague when it comes to the definition part, but basically a function calling itself is called as a recursive function. So when you make the final call to that particular function, you need not call the function further. So we are going to see what are the cases that we have in recursive function. Basically, to solve a particular problem, we have two solution or two cases of solution in recursive functions. The first one is the base case and the second one is the recursive case. So base case is one particular scenario where you are going to make the final call to the function which does not require to call itself. So no more function call is going to happen in the base case. Whereas in the recursive case, we are going to perform three tasks. The first task is we are going to divide the problem into subproblems or the subparts. Now every subpart will call the function itself obtained from the previous step, and the result of all the subparts are combined in order to gain the final result. So this is something about the basic concept of a recursive function. So next we will see how we can understand the concept of recursive function with a small illustrative example. So basically factorial is one of the common easiest example to make you understand the concept of recursion in any programming language. Yes, of course recursive functions are available in any programming language. So here what I'm going to do is I'm just going to produce a small code snippet and I'm going to explain the concept of recursion. So first thing is we are going to see what is a factorial. A factorial is something that you are going to multiply a number with the factorial of a particular number that is 1 less than the number. So let's say for example I want to identify the factorial of a number that is n. So n factorial has got the formula that is n into n minus 1 factorial. So if I want to identify what is the factorial value of n, then I should multiply n with the factorial of n minus 1. So that is what I tell you, a factorial of a number that is 1 less than the number. You have to multiply a particular number with the factorial of that particular number that is 1 less than it. So n factorial is equal to n into n minus 1 factorial. So this is a normal school day mathematical formula. Now here, if you want to identify what is the n minus 1 factorial, so n minus 1 factorial has a formula that is n minus 1 into n minus 2 factorial. So with respect to the previous step, that is n factorial, we have got the value that is n into n minus 1 factorial. So what will be the value of n minus 1 factorial? So it will have n minus 1 into n minus 1 minus 1 factorial, that is n minus 2 factorial. Then what will be the value of n minus 2 factorial? It will have the value n minus 2 into n minus 3 factorial. So like this the steps keeps on going. So let's say for example I want to calculate the factorial value of 4. So if I want to calculate the factorial value of 4, first I have to calculate 4 into 4 minus 1 factorial, that is 4 minus 1 factorial is 3 factorial. So if I want to obtain 3 factorial, then I have to calculate what is 3 into 2 factorial. And if I want to calculate 2 factorial, then I have to understand what is 2 into 1 factorial. So once this expansion has been properly solved, so what happens is first 1 factorial will be solved, that will return me a value that is 1. So as I told you here, when I say about 4 into 3 factorial, first and foremost thing is we are looking for what is the 3 factorial. And when we try to solve 3 factorial, we get 3 into 2 factorial. And when we try to solve what is 2 factorial, we are getting the factorial value that is 2 into 1 factorial. So first 1 factorial is getting solved. So 1 factorial will give me a value of 1. So that is going to be the base case. Why? Because we are not going to perform the factorial operation again on 1. So this is going to be the base case where you are not going to perform the factorial operation again. So if you take this particular scenario, what happens here is first the value of 1 will be returned and 2 into 1 will be given as the result of 2 factorial, and 3 into 2 factorial will give me a value of, so 2 factorial has got the value that is 2. So 3 into 2 gives me the value of 6, and 6 is going to be the outcome of the 3 factorial. So 6 again multiplied by 4 will give me the value 24. So that will be the factorial value of 4. So this is how the operation is going to happen. So now, as I told you, so 2 into 1 factorial will be solved first. So when I try to solve 2 into 1 factorial, 1 factorial has got the value that is 1. So that will return me the value that is 2. So so the result of 2 is going to be the 2 factorial, and this 2 factorial will be served as a value that will be multiplied with 3 in order to get the 3 factorial. And if I want to retrieve the 4 factorial, then I have to multiply this 3 factorial again with the value that is 4. So this is how the working style happens for factorial. Now I'm just going to write a small code snippet. That is, I've declared a function that is factorial. I declared a function that is factorial. This return type of this particular function is going to be integer, and this particular function is going to accept an input argument that is x of integer data type. Now I write my code snippet for my main function definition. So in my main function, what I have done is I have declared a variable a that is of integer data type, and the value of a is 4. Now in the next statement is a printf statement where I am printing an integer value through the character format %d, and here I have a function called that is factorial of a. So when this particular statement is executed, first what happens is the function is getting called. So immediately the control passes to the function definition. So in my function definition, what happens is you have the header that is int factorial, so name of the function as well as the return type of the function is given, and then the formal parameter value is x. So what happens is the value of a is got a copy through the variable x. So a has got the value 4, that is actual parameter, and this value, this is actually a function called by value. So what happens is 4 is getting passed to the function definition, and a copy of 4 is being taken into the formal parameter that is x. So x has got the value 4 now. Now inside my function definition, what I see is I'm just making comparison, that is if x value double equals 1. So double equals is a comparison operator. So the value of x has been compared with 1. So x value has got the value that is 4 now. So 4 is compared with 1. So if 4 is compared with 1 and if that value is true, then it should return, this particular function will return me a value that is 1. But here 4 is not equal to 1. So what happens is here we write the else case. So in the else case, I have a return statement. This statement will return x into factorial of x minus 1. So x is having the value that is 4. So 4 into factorial of 4 minus 1. So 4 into factorial of 4 minus 1. So now here x value is equal to 4. And so this particular statement will return me the value that is 4 into factorial of 4 minus 1. So 4 minus 1 is equal to 3 now. So what happens here is again the function is getting called. Now the function is getting called. Now x takes the value that is 3. Now 3 is compared with 1. The condition fails, and then it is going to return to the else part, and in the else part you see it is going to return, this particular function is going to return, that is x into factorial of x minus 1. That is x value is 3. So 3 into factorial of 3 minus 1, that is 3 into factorial of 2. So again what happens, the function factorial is getting called with x value is equal to 2 now. So when I call this particular function factorial with x value is equal to 2, so again x is getting compared, that is 2 is getting compared with 1, the condition fails. So you go to the else part. So in the else part we are going to return x into factorial of x minus 1, that is 2 into factorial of 1. So factorial of 1, again what happens is the function is getting called. So remember here in all these steps we have not solved the value of factorial of 3, the value of factorial of 2, and the value of factorial of 1. So now what happens is the x value becomes 1 here, and again this function is getting called with x value is equal to 1. The factorial function is getting called with x value is equal to 1. Now 1 is compared with 1, the condition is true. So now what happens is this particular function is going to return me a value that is 1. So the outcome of factorial of 1 will be the value that is 1. And so once this is getting solved, so factorial of 1 is 1, so 1 is getting multiplied with the 2, 1 is getting multiplied with the 2, so 2 into 1 becomes 2, and that becomes a solution for factorial of 2 now. So factorial of 2, we have got the value that is 2 now, so 2 is getting multiplied with the 3 in order to get the value that is 6, which will be the factorial of 3. So 6 is getting multiplied with the 4. So 6 into 4 gives me a value of 24, and that 24 will be returned to the calling function. So calling function is my main function, so this 24 will be returned to the calling function. So the value of 24 will be printed in my main function. So this is how the recursive function works. So basically when we try to pass the value of x value as 4 initially, what happens is the condition fails. So in the else case, what happens is, so this particular x value is equal to 1, that is returning the value 1, is going to be the base case. Why? Because we are not going to call the function again. So this is the base case, and the else part is going to have the recursive case where we are trying to call the function again and again. So we are breaking the given problem into sub problems. So when the problem is being given, I have to identify the factorial value of 4, but 4 is being broken down into 4 into factorial of 3, and 3 in turn is broken down into 3 into factorial of 2, and 2 is in turn broken down into 2 into factorial of 1. So once factorial of 1 is being encountered, the function factorial is getting called with x value is equal to 1. So when x is equal to 1, the base case is being executed. So the base case is not going to call the function again, so it is returning me a value of 1. So factorial of 1 value is going to be 1, and it is multiplied with the value that is 2, so that we can get the result of factorial of 2. And 2 is getting multiplied with the 3 in order to get the value 6, and 6 is going to be the outcome of factorial of 3, and 6 value that has been multiplied with 4 will give me the factorial value of 4. So this is how the factorial function works. So next let us see what are all the advantages and disadvantages of the recursive function. So one major advantage of recursive function is the code is very short and simple, and it is very clear and easy to understand and use the code. And also it is going to follow the divide and conquer technique, especially the recursive function. So where we are going to, whenever a problem is been given, so it is applicable only for solving complex problems or complicated problems. So what we can do is we can break down the complex or the complicated problems into sub problems, where you can apply the method of divide and conquer technique. So you can solve the smaller problems, and then you can combine the results of the smaller problems in order to achieve the solution for the complicated problem. So it is very efficient in order to use the recursive function. So once the recursive function has got the own advantages, it has also got its disadvantages. So one major disadvantage is even for the learners or for the programmers, it is being interpreted as a very difficult concept to understand and use, and it is very difficult to implement, since suppose if your stack space is pretty limited. So always remember, all your functions are going to get executed only on the main memory. So the main memory will make use of the stack data structure in order to implement your functions. So whenever there's going to be some shortage in the stack space, then it is very difficult for you to implement the recursive function. So this is one of the disadvantage when it comes to the recursive function. And if you are trying to abort the recursion in the middle, it is the process of aborting the recursion function in the middle is going to be a very slow process, and it takes more time and memory to execute the recursive function. And one more thing is that it is very difficult to identify the bugs. So in case of any malfunctioning, or in case of any wrong logical operation, it is very difficult for the programmer to identify where the bug has happened. So these are some of the advantages as well as the disadvantages when it comes to the recursive functions. So if you have any queries or doubts, you can post the questions as well as your doubts in the comment section. Thank you for watching this video.